Welcome back to the Gen AI interview series. Here's the question ending senior AI engineer interviews right now. Your RAG pipeline is live, users are getting answers, everything looks fine. How do you know it's actually working? Most engineers say, we check accuracy and stop. That's not an answer. That's hope dressed up as engineering. RAG pipelines fail 40% of the time at retrieval, and the model doesn't know. It takes the wrong context, generates a confident, well-structured answer, and ships it. No error, no warning. Just a hallucination that looks like a fact. And 80% of those failures, they don't start at the model. They start at chunking. Weeks before the first user touches your system. Same interview question, real answer. Let's get into it. First, let's understand why this is hard. RAG looks simple on paper. Chunk your documents, embed them. User asks a question, retrieve the closest chunks, feed them to the model, get an answer. And it works in a demo on clean documents with simple questions. Production breaks every one of those assumptions. Your corpus is messy, PDFs with tables, scanned documents, policy files written in 2014. And the user's question uses completely different vocabulary than your document. How do I cancel my subscription? Doesn't semantically match account termination policy. Vector similarity says they're close. Retrieval says they're not. Wrong chunks go in, the model doesn't know, the answer comes out confident and wrong, and your user makes a decision based on it. That is the wall. The only way through is a proper evaluation stack. So here's how we break this down, and this is important. Most teams treat RAG as one thing to evaluate. It isn't. It's a chain of decisions, and each link can fail independently. That's what makes it hard to debug. A faithfulness failure looks exactly like a retrieval failure if you're only measuring the final answer. You need to instrument every layer separately. 4 layers. Each one catches failures the previous layer misses. Layer 1, chunking, where 80% of RAG failures are born. Layer 2, retrieval quality, precision and recall. Did the right chunks come back? Layer 3, generation faithfulness. Did the model actually use what you gave it? Layer 4, production observability, catching drift before your users do. No single layer catches everything. Let's dive in. A 2025 study comparing chunking strategies found naive fixed-size chunking produced faithfulness scores of 0.47 to 0.51. Optimized semantic chunking, 0.79 to 0.82. Same documents, same model, just smarter splitting. Here's why. Fixed-size chunking splits at 512 tokens, regardless of where the sentence ends, where the idea ends, where the table ends. Paragraphs break mid-thought. Questions separate from their answers. The chunk goes into the vector database as a fragment and retrieves as a fragment. And you can see the failure right here on the diagram. Fixed chunking cuts straight through document structure. Context lost at every boundary. Semantic chunking respects natural breaks, preserves meaning, retrieves complete ideas. Production rule. semantic or recursive chunking with sentence boundary detection, chunks between 300 and 500 tokens, 10 to 15% overlap, so boundary context isn't lost. Get chunking wrong, and no amount of model tuning saves you. Get it right, and retrieval improves before you change a single line of retrieval code. That brings us to layer 2. Most teams measure RAG quality by asking, did the user get a good answer? That's output evaluation. By the time you measure the output, you've already shipped the failure. Retrieval evaluation catches failures earlier. Two metrics that matter. Context precision. Of the chunks retrieved, how many were actually relevant? Retrieve 10 chunks, only 2 are relevant. Your model reasons across 8 chunks of noise. And here's the key insight. The model doesn't hallucinate because it lacks knowledge. It hallucinates because irrelevant context confuses generation. Context recall. Did the right chunk come back at all? It exists in your corpus. Did retrieval surface it in the top K? If not, no amount of generation quality saves you. Two different failures, two different fixes. The tool that automates both metrics is Ragas, Retrieval Augmented Generation Assessment. It uses an LLM as judge approach to score your pipeline without needing manual labels. Above 0.8 on context precision and faithfulness, production ready. Below 0.6, you have a retrieval problem, not a model problem. The fix for low recall? Hybrid search. Pure vector search misses exact keyword matches. Pure keyword search misses semantic meaning. Hybrid combines both. Vector similarity plus BM25 merged through reciprocal rank fusion. Think of RRF as a voting system. Each search method ranks the results independently, and RRF combines those rankings to surface what both methods agree on. In production, hybrid consistently outperforms vector only by 15 to 25% on recall. But even perfect retrieval doesn't guarantee the model uses it. That's layer 3. Layer 3. Did the model use the context you gave it or go off script? Your retrieval is perfect. Context precision 0.9, exactly the right chunks. And the model still hallucinates, blending retrieved context with training knowledge, drifting off the source, generating something that sounds right but isn't grounded in what you gave it. Faithfulness score catches this. It checks whether every claim in the model's answer traces back to a retrieved chunk. If the model says something not in your context, faithfulness failure. Ragas computes this automatically. Target above 0.8. Below that, your model is generating beyond its retrieval. And in a financial or legal context, that's a compliance risk, not a quality risk. The fix: explicit grounding instructions in your prompt. Answer only from the provided context. Do not use prior knowledge. Combine with citation requirements. Measurably improves faithfulness scores. And that brings us to where most teams fall apart: production. Evaluation at launch is not enough. RAG systems drift. Your corpus gets updated. Query patterns shift. A policy document gets rewritten. Chunking that worked in January breaks in March, silently. You need live evaluation, every query, not sampled, every query. What to track? Faithfulness per query, context precision trends, retrieval latency, hallucination rate flagged by an LLM as judge running in parallel. Tools: Ragas for offline evals, Langfuse or Phoenix for production tracing. CI/CD quality gates. Before any change to chunking, embedding model, or retrieval pipeline goes live, run your eval suite. Faithfulness drops below threshold, deployment blocks. Same discipline as any production software applied to your AI pipeline. One number to remember: 95% accuracy at each of 5 layers: chunking, embedding, retrieval, re-ranking, generation, gives you 0.95 to the power of 5. That's 77% end-to-end reliability. RAG fails silently at the seams. The eval stack makes those failures visible. One query, all 4 layers. User asks, layer 1 already ran. Semantic chunks with preserved boundaries in the index. Retrieval runs hybrid search, vector plus BM25, RRF combines scores. Layer 2 checks context precision. Re-ranker filters noise, keeps signal. Model generates. Layer 3 checks faithfulness in parallel. Every claim traced to a retrieved chunk. Above 0.8, answer ships. Below threshold, flagged or fallback triggered. Layer 4, watching the whole time. Hallucination rate nominal. Corpus version current. Drift alert if query distribution shifts. That's production RAG, not chunk, embed, retrieve, generate. That's a demo. Production is the evaluation stack that wraps every layer. Start with Ragas. Add Langfuse for tracing. Use Cohere re-rank. 50 millisecond latency cost, meaningful precision gain. Pinecone or VV8 for hybrid search at scale. Compose what your workload needs. RAG evaluation is not glamorous, but 47% of enterprise users made at least one major business decision based on hallucinated RAG content in 2024. Everyone traces back to a pipeline nobody properly evaluated. 4 layers: chunking quality, retrieval precision and recall, generation faithfulness, production observability. That's what separates a RAG system that looks good in a demo from one you can put your name on. And that's what the interview is really asking. Not, have you built a RAG pipeline? Every candidate has. The question is, do you know when yours is lying to you? And here's the bigger thought. Get this stack right, and you're not just evaluating today's pipeline. You're building the discipline that scales to agents, to multi-hop RAG, to whatever comes next. Which layer would you fix first in your current system? Drop it in the comment.